This is Mr. Anderson from Keller Community College doing the Chapter 5 test review. These are problems that are similar to and could be included on the next test. I will not be checking my answers on the calculator, but I want to encourage you to use your calculator at the end of each problem to check your answer to see where they intersect the x-axis, or use FOIL to go back and check the original problem. Now, what I will be using in terms of my method for determining how to solve these problems is I will be using the technique discussed in class for section 7, and that will essentially go over just all the different types and forms of factoring. So the first thing we're going to do is start off with problem 1 here. The first question I ask is there a common factor that can be removed from each of these terms? The answer is no. Second question is, how many terms do I have? I have 3. And my third question is, what is the first number in the problem? Is this going to start with a 1 or not a 1? And since this starts with a 1, this is going to be easy factoring. What I do is list all the factors of 16. In this case, it would be 1 and 16, 2 and 8, and 4 and 4, and find the combination that makes the negative 8 in the middle. And that would be 4 and 4 if both of them were negative. Since 2 negatives multiply to make a positive 16, and 2 negatives add to make a negative 8x, my answer is going to be x minus 4. X minus 4. Or x minus 4 quantity squared. But we're not going to be putting that together here because in the next chapter we're actually going to like them separated so we can do some simplification. Problem number 2, the first question is there a common factor I can remove from the problem? And the answer is yes, you can remove a 6. And in doing so, that's going to leave you with 6x squared plus just 1x minus 2. Now, I then ask myself, since we've already eliminated or factored out the 6 from the problem, how many terms does it have? It has 3. And check the first number in that trinomial, and it's a 6. So we have to use the tricky trinomial factoring method, where we're going to turn this into a 4-term problem using grouping. So 6 times negative 2 is going to be negative 12. And I have to think of all the different ways I can make 12 now, and that's going to be 1 and 12, 2 and 6, and 3 and 4. Now, what combination of 3 and 4 can make a 1? Since 2 and 6 can't make a 1 and 1 and 12 can't make a 1, 3 and 4 can make a 1 if the 3 is negative. And that also syncs up with my numerator, or not numerator, the factors of negative 12, because negative 3 times 4 makes negative 12. Now I'm going to split this like so. So I'm going to have 6 parenthesis 6x squared minus 3x plus 4x minus 2. Now, this is a 4-term factoring problem, so I'm going to group it. I'm going to take the first 2 terms and group them together. So I'm going to factor out a, let's see here, we can factor out a 3x from the first 2 terms here, which gives me a 2x minus 1. And I'm going to factor a 2 out of this next set here, so this gives me a 2x minus 1 here. And I should feel pretty good about myself since I have a pair, 2x minus 1s. I take my leftovers, which is my 3x plus 2, put that inside of a single parenthesis, and then I'm going to take my matching pair, my 2x minus 1, and I'm going to put that together. And don't forget the 6 was pulled out at the beginning of the problem, so I have to have that 6 out in front. And this problem is not completely factored unless the 6 is out in front. If you didn't actually pull the 6 out in front, you would have a myriad of different answers here, with the 6 being distributed or a 3 and a 2 being distributed to either of these. So I would keep your answer like this. This is what I would expect, since in the next several chapters we want them completely factored for simplification purposes. Alright, in problem 3, like problem 1, we have nothing to factor out of these 3 terms, and we just look at the factors of negative 28. And the factors of negative 28 are 1 and 28. We have 2 and 14. Checking a while to see if we can make a 3, and we can't. And we have 4 and 7, and this is the magic number, because if I make the 4 negative, this will give me my two numbers to multiply to make negative 28, and add to make 3. So my answer is going to be x minus 4, x plus 7. Okay, now we're going to move to the next 2 problems here on this page, problems numbers 4 and 5. Okay, so in problem number 4, can we factor anything out of the problem? And the answer is no, we can't. And we cannot factor anything out of the problem, so what we're going to do here is we're going to ask how many terms there are. and there are two terms in the problem. This means that we have to ask ourselves, is this a difference of squares or is this a cubes problem? And since this is an even power, this is going to be a difference of squares. So what I'm going to do here is use my pattern for difference of squares, take the square root of x to the fourth, which is x squared, and take the square root of 1, which is 1. In my difference of squares patterns, I have 1 plus and 1 minus. Now this right here is only partial credit because if you look at the second binomial, this can be split again, since it is also a difference of squares. As I explained when I was teaching this, that I will be looking at some place in your test where you're going to be pushed on this, you will have a problem with a difference of squares that might be able to go one more time. So a little hint for that is look for the even number that's bigger than 2. So here's my x squared minus 1, and that splits off here. So my answer is going to be x squared plus 1 times the quantity of x plus 1, x minus 1. Make sure that these are opposite symbols, plus and minus, and make sure you always look for that extra step there. In problem number 5, one of the more challenging problems on this page here, we see if there is a number we can remove from each of these, and the answer is no, because 3 is not divisible by all 3 of these terms, and 3 is a prime number. So we are pretty much stuck with what we have here, so we have to multiply 3 times. This is a tricky trinomial. So like in problem number 2, we're going to solve this the same way. 3 times negative 28 is going to be negative 84. Now since 84 is a big number, I'm going to pay close attention to see when I can make the 25 in the middle here. 1 and 84 have no way of making 25. If you subtract the two numbers, there's no way. 2 and 42 have no way of making 84 because that just makes 40 when you subtract them. Now let's try 3 and 28. Now that actually does make 25 if I subtract the 28. Now what's important about that is you'll notice that the 28 has to be negative, not the 84. So let's split this up. So if I split this up, this is going to be 3x squared plus 3x minus 28x minus 28. I just took the 25x and split it with the 3 and the negative 28. Now I look at, since this is a 4-term problem instead of 3 terms, I'm going to group it. So I'm going to factor out a 3x, which gives me x plus 1. Now here I'm going to factor out a negative 28. Anderson's pro tip number 2 from a video from a long time ago is to make sure that you factor out a negative when you can, and that will make sure our x plus 1 is in the middle. Now what's nice about this, my answer is going to be the leftover pieces together inside of a parenthesis like that, and then we have x plus 1. So there we go. There's our problem. Okay, let's move on to the next piece. The next piece is going to be number 6 here. We're going to go through these next 3 problems here. Okay, so this is a problem where we can't take out anything from the problem. Notice that we can only maybe divide by 1, but that's not going to help. This is a binomial, and we got to ask ourselves: is this a difference of squares or is it a cubic problem? And this is a square problem, but you notice this is not a difference of squares. So this answer is prime. Prime means you can't factor it. If you actually looked at this on the graph, the y-intercept would be 4, and it would go up from here. And our solutions have to have, our solutions are where the parabola intersects the x-axis. So this doesn't actually work here. Alright, now in this problem here, this is a problem where we cannot factor anything out of the entire problem, but you'll notice that it's not written in order, so it will help us if we write this problem in order, like so, and then go through those questions. There's nothing I can factor out of this problem, and secondly, you'll notice that there is 4 terms in the problem, so this is going to be a grouping problem. If I pull out x to the 5th out of the first 2 terms, that's x minus 1. Now, look at here. What do I factor out of these 2 terms? There's nothing I can factor out, so I'm going to factor out a 1. So this is going to be x minus 1. So now I'm going to get to my final answer, which is x to the 5th plus 1. And then we have x minus 1. Now this is where I'd want to be careful to see if this was maybe x, a cubic. Maybe we could use some SOPs on that, which I will show you in problem number 11. And also, if this was an x squared, you could go further. But this is done the way it is right there. Now, this problem here, I think you might be a little sad to see that you can't actually remove a common factor from this problem. And you can't because 16, 24, and 9, there's not a common number to divide each of these numbers. But so you're thinking about, okay, 16 times 9, you get the calculator out, that's really big. But this is a problem where if the first term is rootable, like you can take the square root, and you should probably look at this sometimes if you can. The first problem is rootable, so the square root of 16 is 4x, 16x squared is 4x, and the square root of 9 is 3. You know what you might want to try is you might want to try 4x plus 3, 4x plus 3. Now, to check, I would make sure, since this is a timed test, you should maybe be on the lookout for a problem where the first and last term are rootable, but then you should go back and FOIL it to make sure you got the answer right. So if I do FOIL, I'm not going to really care about the first or last term because I think 4 times 4 is 16 and 3 times 3 is 9. But we got to be careful that we make the 24 in the middle. So 4 times 3 is 12, 4 times 3 is 12, so we do make our 24 because we have our 4 times 3 plus 4 times 3. So this does work. You can actually do this the old way, but the old way will get you this answer, and I suggest trying that on your own, like problems numbers 2 and 5, just so you can see that it works out the same way without the shortcut. So it's not really necessary for you to know the shortcut, but it just would save some time. Alright, here's problem number 9, a real doozy of a problem. Because problem number 9, the faster you are, the more you might miss. Because it's true that this is nothing I can't factor anything out of this problem, and I also, you know, it's a trinomial, so it's an easy trinomial. You might be tempted to go, you know, x minus 1 and then x plus 5. But the problem with that is that you'll notice that this is a positive 5. And since it's a positive 5, you got to multiply by 1 and 5 positively. Therefore, there's no way you can make a 4 because you would have to make this a minus 1 and then that would make that a negative 5. So this answer is prime. This actually might have answers, but we would need to use decimals or the quadratic formula we will use in Chapter 8. So look out for tricks like this. There might be one of those on the test. Also, a special note about prime. Don't expect a lot of them on the test. In fact, if you put more than maybe 2 problems as prime, you should go back and check your work. Okay, problem number 10 is kind of a fun one because this one penalizes you if you don't know the first rule of factoring. The first rule of factoring, you should look for a common term. So if I factor out a 3, because each of these are divisible by 3, I got x squared plus x minus 6. Now, what's important about that is that we just went from a tricky trinomial to an easy trinomial, because right now I just have to look for 2 numbers that multiply to make negative 6 and add to make 1. Well, 1 and 6 don't work, but 2 and 3 sure do if I make the 2 negative. So this is going to be 3 times the quantity of x minus 2 and x plus 3. Alright, so my answer is that, but again, what's important about this is that the answer is when, you know, after you factor out a 3. Now, if you didn't factor a 3 out, you're going to have an answer at the end that's going to be like 3x minus 6 and x plus 3. And that means that this problem will be partially wrong because you can factor a 3 out of this this binomial here. Or you could have this as your answer. You could have x minus 2 and 3x plus 9. Now look at your 3x plus 9. You could factor out a 3 here and move it to the front. So anything above this line will be not fully, not for full credit on the test because I expect all of my answers to be fully simplified because in the next chapter we're going to need that to do some simplification. So always follow the first rule of factoring, which is remove a common term. Now in problem number 11, there's no way I can remove a common term from 125 and 64, and also we have a binomial here. So this should be a big clue for us to use a either difference of squares or cubes. Now this is a cubic problem, so we're going to use the SOPs. Now we're going to start off by picking our A and our B term. Now our A term is going to be the cubic root of the first term here, which is going to be 5x. And the cubic root of the last term is going to be our b, which is going to be, in this case, negative 4y. And that's important to know because taking the cube root of a negative stays negative. So our pattern of our trinomial is called SOPs. So we take our a and our b, which is 5x minus 4y, and then we make a very large trinomial here for our s, op, and s. The first s of SOPs is to square the first term, so this is 25x squared. The op is the opposite product, so the opposite product is going to be negative 20y, or sorry, xy. Sorry, I forgot my little x there too. And then my last term is going to be the square of the second term, or this one here, which is going to be positive 16y squared. So I'm sorry that's so sloppy there, and I apologize for my my little light pen action here, but this is going to be 25x squared minus 20xy plus 16y squared. So my final answer is that, this whole set here, the binomial of 5x minus 4y and the trinomial of 25x squared minus 20xy plus 16y squared. Now this moves to our back page. Our back page of our test is worth double points. Each problem is worth 2 points, a problem for factoring it, and then a problem for solving it with our answers. Now you'll notice the difference between these last 3 problems and the problems you've done before is these last 3 problems are set equal to 0. Which means that we have to find when they hit the ground. So there's an extra step once you're done factoring. So this is a tricky trinomial because there's nothing we can remove from each of these 3 terms. Moreover, what we'd have to do is we have to now turn this into a grouping problem. So we're going to multiply 3 times 4, which makes 12. This is my little scrap work here. Now I've got to make a negative 8, so let's try 1 and 12. Nope, that doesn't make 8. Let's try 2 and 6. That does it, but I'd have to make both of them negative to make a positive 12 and a negative 8. So I make my split symbol here, 3x squared minus 2x minus 6x plus 4 equals 0. So your first half of getting the problem right is to factor it completely correct. So the only thing I can factor out of these 2 terms is an x, which is going to be 3x minus 2. And the only thing I can factor out of these 2 terms is going to be a negative 2. So if I'm going to factor out a negative 2 here, and remember Anderson's pro tip of pulling out a negative because this gives me a positive 3x minus 2. And I'm going to set this equal to 0. Now the stuff that's all by itself, x minus 2, that gets put together, and we write the 3x minus 2 once equals 0. Now this is for half the credit of the problem. The other half of the credit of the problem is to find where this hits the ground. And what I'm going to do is set this equal to 0. Each one of these is going to hit the ground at 0, so I have to check when each one does. Now in this first problem, I'm going to add 2 to both sides, so x is equal to 2. And here I'm going to add 2 to both sides here, so I get 3x is equal to 2, and then divide by 3, so x is equal to 2/3. So what I have here is I have the answer is my set of 2/3 where it hits the ground, and also 2. Now understand, I've been saying when it hits the ground, but if you look at this on a graphing calculator and you type in the original equation, it will cross the line at 2, and it will cross the line, the x-axis, at 2/3. It's just going to be kind of hard to see, because 2 is very easy to see, but 2/3 might be right down there. So it's going to kind of swoop down and move back up again. And using any graphing calculator will show you this. Okay, so let's go to problem 13. Problem 13, the first thing we need to do is we need to bring the 14 to the other side. We have to find out when this hits the ground. So I want to know when it hits the ground, so let's bring this over to the ground, to the left-hand side. Okay, so what I'm going to have is x minus 3 and x plus 2 minus 14 equals 0. So now what I'm going to do is FOIL this out here and then put my 14 with it. So that will help me out when I hit the ground. X squared plus 2x minus 3x minus 6. And this is why I had you practice FOIL in sections 1 and 2, because I needed you to be able to do this for this problem. And I still have my minus 14 here equals 0. Okay, so let's combine like terms here. I got x squared minus x, and then I have negative 16 minus 14, which is negative 20, equals 0. So now I have a easy trinomial because there's a 1 in front of the x squared and there's nothing I can factor out. So I have to list all the factors of 20 and see which ones make negative 1. Alright, so 1 and 20 don't make negative 1. 2 and 10 don't make negative 1. 4 and 5 do, if I make the 5 negative. So this means my answer is going to be x plus 4, and I'm going to have x minus 5 equals 0. So that's for half of the problem right there. Now for the other half of the problem, I'm going to have to commit my answers to 0. So I've got x plus 4 is equal to 0, and I've got x minus 5 is equal to 0. Subtract the 4 from both sides, add the 5 to both sides. X equals negative 4, x equals 5. So here's my set. -4, 5. All right, so our next problem is going to be to take a look at, this is our last problem here. If you notice that if you double these last two problems, so this would be 12, 13, 14, 15, 16, 17, we are going to have a total of 20 problems. So there are some problems I have not given to you on this practice that are on your test, and that is with the warning that anything on your homework was fair game. So if you've did your homework, then you basically have practiced every single problem that could appear on this test. Now, the rule 1 of factoring is to remove a common term. And remembering Anderson's pro tip number 2 is to always pull out a negative if possible. So we can remove a negative x from each of these problems here, and this would give me x plus x squared, plus x minus 12 equals 0. Now what this makes me do is this makes me then solve this trinomial on the inside. It's an easy trinomial. It's -12, and I've got to find a combination that makes a +1. So 1 and 12 don't make 1 when you subtract them. 2 and 6 do not make 12 when you subtract, or 1 make when you subtract them, but 3 and 4 do if the 3 is a negative. So therefore, my answer is going to be inside of this trinomial here, x minus 3, and x plus 4 equals 0. Now this is for half the points. The other half the points is to find our 3 answers to the problem, because what we have here is -x equals 0, we have x minus 3 equals 0, and we have x plus 4 equals 0. So what I'm going to do here is solve for x each time, which will give me 3 answers. Dividing both sides by -1, x could be 0. Adding 3 to both sides, x could be 3. And subtracting 4 from both sides, x could be -4. So my answers to the problem are threefold: -4, 0, and 3. Reminder, when we write sets, please write them from lowest to highest value. And this is a finite set because there are only 3 answers when this equation crosses the x-axis. And if you type this into a graphing calculator, roughly speaking, it will cross at -4, 0, and 3, like this. Now, I'm not necessarily getting the height or depth of this twist in the exact place. I'm not sure, it could be higher or lower. But right now, oh shoot, I drew it the wrong way. Ah, darn it. Because of the negative in front of the x cubed, this has a different twist to it, and this is something we'll be exploring later in a future chapter. It actually comes, it's actually going down overall because of the negative x cubed. I should have caught that as soon as I was doing it. But again, if this graph kind of puzzled you a little bit, we'll be exploring this more in chapter 7 and 8. So thank you very much for working so hard and getting through the video. Study up, do this practice test more than once, and do the other optional reviews that I've given out in class to help you prepared for this test, which could be your best grade of the semester. Thank you for watching.